Yeah, a few things about last class I'll just tell you. There's one question which was pending, what is alive method? That you can write it down. Okay. These are related to last class. What is alive method? This method is used to check whether the thread is alive or dead. It returns a boolean value, true or false. If true, thread is alive. If false, thread is dead. This is one question related to is alive. One more thing, when I showed you some last examples, last two examples, okay, they were actually present in the second project. These two, I didn't highlight it. Like I showed you two programs, running to runnable and priority demo. These two programs are in the second project. Okay, in the first project I got 9 examples. Okay, and in the means all the first examples are there in the first 9 examples are in the first project. The next two which I showed you are there in the second project. So this is these are the things related to previous class. Okay, so today we'll continue with synchronization. Okay, so today we'll start off with synchronization, a new topic related to multi-threading. A new topic related to multi-threading. Actually, do you know the meaning of synchronization? What is the actual meaning in English? Forget multi-threading now. These are English words which have been used in programming, means computer. Okay, computers. That's it. But basically, what is the meaning of synchronization? Synchronization means many things happening at the same time. Many things happening at the same time is called as synchronization. That is the actual meaning of synchronization. So here also in your programs, many things will happen at the same time. Okay, I mean to say that what will happen is, see, you have created multiple threads now. Till now you have seen multiple threads. Till now you have seen multiple threads. So you can have multiple threads now. This is one A thread, and you can have one B thread. So everything was fine till now. They were having their own run method. This was the run method of A. This is the run method of B. Fine, everything was fine. Now what will happen is, this run method, okay, can do anything. It can create objects of other classes, everything it can do. But sometimes what happens is, the very important thing to understand now, two threads will be working on a same object. Two or more threads. There will be an object called as hello now. There will be an object called as hello. Okay, this is an object. Hello object. So both the threads will be working on what? Same object. In fact, when they work on hello object now, there will be a method. In hello object, there will be a method. I mean to say, see, this is hello object, and there will be a method, M1 method in which one? Hello object. So both of them will be executing the same method at the same time. This is the scenario we will be seeing now. Two threads. We know how to create multiple threads. All this we know now. But actually the thing what we have to cover now is, when two threads access the same object, what happens? You know how to create multiple threads. The scenario is very simple now. When two threads access the same object, what is going to happen? Okay. So in fact, sometimes you get inconsistent results. I'll show you what happens. Okay. So that is when what happens. When two threads are trying to access one object, we do not want both the threads to access the same object at the same time. We do not want both the threads to access the same object at the same time. That's why what we do, we put something called as a lock. We put something called as a lock onto the object. If you put a lock onto the object now, what happens? When one thread is using that object, another thread cannot use that object. This is the concept. Concept wise, I'm telling you what is synchronization. And how this is going to be supported by Java language, we are going to see. So these are the various problems we face while developing a application. We'll be having an object. That object will be used by what? Object or one resource. It will be used by multiple threads. Okay. By default, what will be happening? All threads can use the same resource or same object at the same time. But there will be some scenario where you do not want multiple threads to access the same object at the same time. Means you want only one thread to access that object at one particular time. That's it. Okay. This is the programming requirement. Now how do you do it? So in Java, we do it with the help of, in all languages we do it with the help of what? Synchronization. In all languages we do it with the help of synchronization. So today we are going to see how to do synchronization in Java. Okay, means first of all, what is synchronization now? It is a process of locking an object so that only one thread can access any object at a same time. Okay, it's a process of, once again, definitive, it's a process of locking the object so that only one thread can access that object. It's a process of locking object. Is a process of locking an object so that only one thread can access that object. So this is what is synchronization, and this feature means this problem will come in whenever you are developing an application. This problem will come, and you can develop an application in any language, yes or no? You can develop it in C, C++, any language. Okay, so this is a big problem what we face, but Java resolves this to such a simple level, it's unbelievable. Okay, this huge problem in Java is solved with one simple keyword called as synchronized. That's it. So we'll be seeing a new keyword also called as what? So synchronization is supported with what? It is, the next point is, it is supported in Java with the help of what? Can access that object. 1 second. In Java it is supported with the help of synchronized. One keyword will solve that huge problem for you. Understood? So first we have to understand what is the problem. Okay, then we will see how to resolve that problem. So this is how you have to learn always. A problem is there. What is the problem now? Right now, multiple threads will access one object. Simultaneously it will accept. There will be some problems. I'll show you what are the problems. And we do not want that to happen. So that's when what we do? We will do synchronization. To do synchronization, we'll use the keyword called as synchronized. Very simple over. Topic is only this much. But I'll give you plenty of examples to give you a concrete, hold on to what is synchronization. So we'll, as I go on telling you, obviously you have to understand the concept now. For every concept what you need? Example. So plenty of examples I'll start giving you. So concept of synchronization is only this much, nothing else. So in the interview, this is what is very important, and it's a very, very important subject in multi-threading. It's a very, very important subject in multi-threading. Okay, shall I clear all this now? So we understood what is the problem and how to resolve that problem. We also understood we'll do it with help of what? Synchronization. So synchronization is a process of locking an object so that only one thread can access that object. Yeah. So now what happens is, so first you have to understand how do you make multiple threads use one particular object, single object. How do you make multiple threads refer to an object? Can you guess? So you should understand now, I want a single object to be used by multiple threads. So you should have the same reference in both the threads, yes or no? So it's very simple. See here, what you will do, I showed it in diagram wise also, code wise it looks like this here. Class A implements runnable. What is hello h? An instance variable. Okay. And in this is hello now. This is the hello class. There is nothing in hello class. There is one simple M1 method. You know what is M1 method now? Simple method is there. A very simple M1 method. There is nothing more here. Okay. The loop and all you forget. But what is there inside this method? What is there inside class hello? One method is there. This logic and all don't bother too much. There is one method called as M1. The same now. See, hello h is an instance variable in A thread. Hello h is an instance variable in B thread. But what am I trying to do? In both the threads, I am not creating a new object of hello. I am not creating an object of hello. Why? Because if I create object of hello in A and B, what will happen? There will be two separate objects. So instead of that, what will I do? I will create it somewhere outside like this, and that I will be passing in as a reference to A thread and B thread. Diagram wise also I'll write it and show it to you. So the same, what address you are giving now will be stored in what? A thread. See here, what am I doing? This dot h is equal to h. How did I initialize h now? By sending the reference. And here also what did I do? By sending the reference. So that is how both the threads are referring to the same object. Very simple. Okay. And at the same time, what am I trying to do? Call the M1 method. So both threads are trying to call what? Same method. Understood now? The concept is what? If you want multiple threads to access an object, create the object somewhere outside and pass the reference to both the threads. That's it. Now both the threads will work on the same object. Clear? Both the threads will work on the same object. Are you clear with this? Are you clear with this? So I'll write this code and show it to you. IE means interrupted exception. That's it. So it's a very simple scenario. This hello object will be used by what? both the threads. Now I'll create two threads here. This is another class, the demo class unsynchronized. Synchronization, unsynchronized demo. Unsynchronized method demo. Synchronized method demo. Synchronization. 1 second. Unsynchronization. Okay, now see. All I'll do is I'll create an object. Hello h is equal to new hello. Yes or no? What will I do? Pass this to what? A is equal to new A of h. B is equal to new B of h. That's it. So once it is done, what will I do now? I'll create the two threads. How will I create? Thread T1 is equal to new thread of A comma, I can give a name, A thread. Similarly, thread T2 is equal to new thread of B comma, sorry, A only. Let pass. Yeah, B comma B thread. Any name I can give. Then I'll say what? T1 dot start, T2 dot start. This is the diagram. Sorry, now I'll draw the diagram. See, let's see when the program goes on executing what happens. So first what happens? An hello object is created now. Here will I draw. This is a drawing diagram. This is object hello. After creating that, what will I do? I'll create two threads. What is this? A thread, and also I'll create what? B thread. Two threads I have created. This is A thread, B thread, because when you create two threads, what will happen? Two stack will be created. This is a separate path of execution, that's a separate path of execution. Both are having what? Run method. Yes, but both are having what? Same h, no? What are both of them having? They are having an instance variable, no? See, this was the hello object which you created. Hello h is equal to new hello. This is that h. Okay, address might be 150. The same has been given to what? This h and this h. H dot m1. H dot m1. How did you do it? You gave the reference by what? Constructor, na? A is equal to, sorry, see this. A is equal to new A. What happened? Are you following now? What has happened? 1 second, I'll write it still very clearly for you. So hello h is on instance variable here. Hello h is on instance variable. You are having one constructor here. You are having one more constructor here. You are having run method here. You are having run method here. Start m1. H dot m1. See, I have done nothing. What code is there in class A? I have written it here. What code is there in class B? I have written it here. This is A thread object. This is B thread object. Nothing I have done. And this is hello object. So in hello object, what are you having? This code you are having. What is that you are having? M1 method. Okay. So first I created hello object. Once I created the hello object, I passed the reference of hello to which one? To the constructor of A. What did the constructor of A do? Takes the reference and initializes its instance variable. And what is B doing now? Same way it will get the value of H in the constructor and it will initialize this one now. Call by reference. So now both the threads are working and a run method starts execution now. So this is one thread and this is another thread. Both of them will start working on what? Same object. This is the diagram actually now. Are you clear with this? You got this point now. How do you make two threads refer to the same object? That is very crucial. Once you know how to make two threads refer to the same object, now next concept is very simple. Next only you have to do what? Synchronization. Understood? First get this point of how you make two threads refer to the same object. Okay, so let's see the output now. Yeah, see the examples for synchronization have been kept in one project called as third project. All the examples related to synchronization have been kept in third project. Understand how I organize this? And here I have got packages. See why I went into packages here is because many times I am using the same class name. It will create a lot of conflicts. So that's why I have gone with packages like this. And every package has a clear name, com.cluster.unsynchronized. But look, at the end of the package there is a number I have given. 1, 2, 3, 4, 5, 6, 7, 8. Means while studying these examples you have to go in the same order. Understood? The last one will indicate what? The flow. Means what? Which is the first example, which one is the second example. Okay, because package names cannot start with numerics now. So that's why what we did, I have given it at the end. So 0 means 1, 2, 3, 4, 5, 6, 7, 8. That's how you have to go. So I'm open the first one now. Which one? com.cluster.unsynchronized. This is the example now. And in this example, this is the this is the file. Which is the file? Unsynchronization method demo, which I have written now. This is the example. So the same thing what I have written here, you can see all the things what I wrote now. So just now, see here, class A implements runnable, class B implements runnable, class hello, and all that. Now see, I will get the output done for you. Once you see the output, see here, what happens. I think you should have guessed the output. Begin, main, end, main. So 3 threads will be there. When I run this program, what happens? Main thread, A thread, B thread will be there. Forget about the main thread. Let's concentrate more on A thread and B thread. Okay. So B thread and A thread, both of them will start execution. Supposingly A thread starts off execution. See, begin of for loop by A thread. Means begin of for loop by A thread. Then what happens? Begin of for loop by, and it goes to sleep. Main thread goes to which one now? Sleeping state. So once main thread goes to sleeping state, still the statements are pending. Has the method completed execution? Has A thread completed the M1 execution? No. Meanwhile, what you are seeing? B thread is also executing what? The same M1 method, and you can see very clearly what is output. Begin of for loop by B thread. Aren't both the threads accessing the same object at the same time? If one is not using it, automatically what happens? Another thread starts using it. Understood? But one method has not at all completed the execution of what? Method only. Has A thread completed the execution of M1 method? No. It went to sleep. Okay, fine. B thread started off using. Then what happens? That also went to sleep. Now both thread will come back. From where? Means from sleeping state where they'll go? They're in running state. They went into what? Runnable state. When they go into runnable state, again they'll come to what? Running. Now which thread will come from runnable to running? No idea. Either B can come or A can come. So fine. B was decided to come now. Once B comes, what is happening? It is printing this one, pending statement. And then the method execution completes. After that, see here, A thread completes. Understood? Means you created 2 threads. Both of them went into new state. From new state, both of them came into, when I said start, they came into runnable state. When I called start, they came into runnable. Out of the 2 threads, one thread was moved into running state. See here, which one was moved into running state? A thread. It went on to execute M1 method. But after executing these many lines, how many lines? Say 4-5 lines, it went into sleeping state. Now B thread has entered the same method and trying to invoke it. It also went to sleep. Now from running, both of them went to sleeping. And from sleeping, both will come to what now? Runnable. In runnable, which one will be picked? We don't know. Either A can be picked or B can be picked. B was picked and it completed the execution of M1 method. Okay, not method, in fact it's still continuing the loop, sorry, it's still continuing the loop. So only, sorry about that, they are only still executing the same method, but the looping is happening there. So A completed the loop and B completed the loop. Then what happens? Again both the threads will start. Again means, see, B continued and end of for loop. Then again B, again like that it goes on. Okay, yeah, just I'll clear the diagram, means all these things, and again explain it for you because it will be confusing now. So shall I clear what I have written? Did you understand how to make two threads refer to the same object? That is clear for you? Okay, I'll clear all this now. Now this diagram we'll keep and process now. So this is what is happening. So what will I do now? Okay, so both the threads are executing the same thing. Are you clear with this now? So sometimes we do not want to do this to happen. So what will I do? I have to put a lock onto the object. For putting a lock onto the object, what we do now? Can you guess? We'll use the synchronized keyword. Now where will that synchronized keyword be used? We are using that method now. M1 method. Use synchronized for what? You are having M1 method, no? This M1 method. Just make it what? Synchronized. This M1 method. That's it. Now see what happens. Synchronization has happened. Till one thread completes the execution, other thread cannot enter now. But both are, see one thread goes to execute this. It is A thread is executing now. A thread is executing. It goes to sleep. B thread tries to invoke it. It cannot. Okay, so now B thread will go into which state? See, let's see the flow now. Begin of for loop by A thread. Okay, and it goes to sleep. It goes to sleep, but when it is sleeping, B thread cannot invoke now. It tries to call the method like previous, but it cannot call it because the object has been locked. Once you use the synchronized keyword, the object will become locked. Once it is locked, okay, now B thread cannot access that method. What will it do? It will go to the blocked state. When the resource is not available, it goes into something called as blocked state. Once it is in blocked state, it keeps on waiting till this object is free now. So A goes on executing, and once A completes execution, then B will come from what? Block state to running state, and running state will start executing the method now. This is the flow. Okay, so just I will remove the synchronized and show you again. See, this is what we are expecting the output. Now it's printing clearly. Till A is completing, okay, B cannot enter the M1 method only. It cannot enter. Earlier what was happening? Both of them are entering parallelly. Concurrently they are using the object. But now it's not possible. Okay, so see, it's up to you now. When you write an application, it's not always that you will try to lock like this. If you want, you can do. If you don't want, leave it. By default, both the threads can access the object at the same time by default. If you don't want, then you synchronize now. So you do synchronization with the help of synchronized keyword. See, without synchronization, what happens here? Both of them will run parallelly. One is sleeping, then other one starts off. Other one is sleeping, like that. Both of them will be executing. Understood? But just one keyword will change the whole scenario now. Now what is that keyword? What does that actually do? Okay, that synchronized keyword is so powerful as actually if you use that keyword now, it will, if that keyword is used for a method, and if a thread invokes the method on that object, see which thread is invoking the method on that object? A thread. A thread is calling, now it is calling h.m1. M1 method is called now. As soon as the synchronized method is called now, the object will be locked. The object will be locked. Okay, and now no other thread can access that object. No other thread. So just you have to enable the lock. You have to enable. So all objects in Java have what? A lock. By default, it is disabled. All objects in Java are having a lock. Okay, by default it is disabled. Why it is disabled? Because we have not used the synchronized keyword. The moment you use a synchronized keyword for a method and you call the method, that object will be locked now. So till that object is free, or unlocked, no other thread can access that object. So once this method completes the execution, okay, now when will the lock be released by the thread? Next question. So when does the object get locked? When a thread calls the synchronized method, the object will be locked now. When a thread calls a synchronized method on an object, the object will be locked. Object is locked, not method. Okay, so see, always we have lock for objects, not for methods. Be clear with this. Every object in Java has a lock. I'm not telling every method has a lock. Every object has a lock. For putting a lock onto the object, you have to just write what? Synchronized keyword for a method. So when this method is invoked, the entire object is locked. This is what you have to clearly understand. When this method is invoked, the entire object is locked. And no other, means one full lock will be put onto this object now. Now no other thread can access that object. So once the object is locked, now the full till the M1 method completes execution, you can do looping or anything. Okay, till that M1 method completes execution, no other thread can access the M1 method. Okay, so the other thread, what will happen now? It will try to call it. It might come to see when this thread is sleeping. You put this thread to sleep for what? 500 seconds now. Somewhere you have written the logic there. See there. Thread.sleep for 500 seconds you have written in the for loop. Even though the no thread is there in what? Running state. So that's why when A thread is not there in running state, it has gone to what now? Sleeping state. B thread comes from runnable to running. And it tries to call the method, but it cannot invoke it. Reason is the object has been locked. Okay, so now B thread will go into what? Blocked state. There is a lock and block, clearly understand. Lock is putting a lock onto the object. If a lock is found on the object, the thread goes into what? Blocked state. If a lock is found on the object, the thread moves into blocked state. Understood? So when does the object see that there is a lock? If some other thread is using that object. That's it. So simple now. Concept is so big. If you want to put a lock onto the object, just use what? Synchronized keyword. So if you use synchronized keyword, synchronization will happen now. Okay, that's it. So synchronization is a process of locking the object so that only one thread can access that object at a time. That's it. Are you clear with this? Is this point clear to you now? Okay, we'll see some more examples. More examples you see, you'll start getting the grip of this now. Okay, more examples if you start seeing now, you'll start getting better grip onto this subject. Okay, before that you can see here. What is synchronization? It's a process of locking the object so that only one thread can access that object. When object is locked by the thread, then other threads have to wait until the lock is released. See, a very clear point. Understood? So the lock has to be enabled by using what? Synchronized keyword. Otherwise, see, all objects have a lock, but the lock has been disabled. Enable the lock by using synchronized keyword. Fine. Now see, in multi-threaded environment, multiple threads will run what? Multiple threads will run concurrently and will try to access single object. Sometimes this can lead to inconsistent results. Because of this, we can stop multiple threads accessing the object and allow only one thread to access the object at a time. And this can be done by locking the particular object. Understood? This can be done by blocking the particular. See, a running thread will enter either a blocked state or waiting state. I'm not showing a waiting state. See, a running thread will enter both. Sometimes it will enter blocked state or it will enter waiting state. Right now I'm showing you blocked state. Right now what I'm showing is blocked state. A running thread will enter either a blocked state or waiting state when it does not get the lock on a particular object. Understood? See, this point you clearly understand. Either a blocked or waiting. Right now what I'm showing is blocked. Are you clear? So now see, again next we'll come to the most important topic. Now we can implement synchronization in two ways. One is method level synchronization. Second one is block level synchronization. So put the heading as what? Implementing synchronization. How do you do it? We can do it in two ways. The first one is what? Method level synchronization, which I just now showed you. The first one is implementing synchronization in Java. Implementing synchronization in Java. Shall I clear this diagram now? Or I'll shift it that side. Later on I'll write this. I'll need it. But right now I'll clear it off. So how do you do synchronization in Java? Okay, we can do it with the help of synchronized keyword. Fine. Now we can implement synchronization is two ways. One is method level synchronization, other one is block level synchronization. I'll be taking the first one now, method level synchronization. See, this is very simple. This is the syntax, method level synchronization. What is the syntax? You'll have a method now. For that you'll use what? Synchronized keyword. We are seeing one more new keyword today. Okay, in the Java we have seen many keywords are there now. This is also called as modifier. It modifies the method in such a way that only one thread can access this object. That's why it's called as modifier. Fine. Now see, this is the syntax. Now how do you write the code? See here, example, class hello, synchronized void m1, finished. This method becomes synchronized. m2, is it synchronized? No. So when you write a class, you have options. Okay. Some methods you can make synchronized, some methods you can make and leave it off as it is without synchronization. So you have both the options. Don't think all the methods in a class should be synchronized. Okay. Don't think all the methods in a class should be synchronized. Some you can synchronize, some you can leave it off as it is. Clear? So this is the syntax now. Okay. So now see, when do you do method level synchronization? It's done when you do not want method level synchronization, when you do not want many threads to access a method of an object at the same time. When do you do method level synchronization? When you do not want many threads to access an object at the same time. That's when you do method level synchronization. Syntax is clear now? Fine. Now see, the lock on the object will be released immediately after the method. The lock on the object will be released immediately after when the method completes execution. Immediately it will be released. So developer is so free now. You just have to concentrate on what? Writing your logic in the method. Putting lock, releasing lock, all that will be taken care by what? Java internally. You don't have to bother about anything here. Understood? Just use the keyword, everything will be resolved for you. Okay. Now see here, the same thing what I showed you now. Assume that there are two threads, T1 and T2, which are trying to use what? M1 method with the, I'm explaining the scenario, the example. The example I'm explaining you. For this what you do now, for this diagram, if you want you can write, see here. Anyway, this one I'll bring it back, I'll remove the synchronized keyword here. Okay, so anyway, this was the example for what? Unsynchronization. Means it is not synchronized. So close it, take the next example. Which one is that? Method, synchronized. So here nothing I have done. I have done the same program. All I have done is what? I added synchronized keyword. So for now you write this program and then you write the explanation for this program, this explanation right. Then you will understand it. Just now I showed you an example now. For that program you write down this explanation. Means with synchronized. This is with synchronized. For this program which one's here? Show the output. So what's happening now? When one thread is using the object, the other thread cannot enter. So how is this happening? That explanation I have given it here. The document is there. Assume that there are two threads T1 and T2 which are trying to use M1 method with the same hello object. When T1 is using object H, then object H will be locked by T1 and T1 executes the M1 completely. T1 method executes the M1 method completely. After the method execution completes, the lock is released by T1. As long as T1 is executing M1, T2 will be in what? Blocked state and has to wait to use that object. After T1 completes execution, T1 will use H object and then executes M1 method. This is the scenario. Okay, so H dot M1, this is hello object. Okay, we can just write one more here, something in the diagram. Okay, I'll add it later on. Just you write hello object. So one object, and in that both are calling what? Same method, M1 method. Are you clear with this? So different threads accessing same method with same object. Are you clear? Okay. Okay. Now one more thing. Sometimes, see from here your interview question starts off. Assume that there are two threads, T1 and T2, where T1 is trying to invoke M1 with H1 object and T2 is trying to invoke M1 with H2 object. Means both the threads will have what? Different objects. Now what will happen? Nothing will happen. They'll run. That will run separately. This will run separately. In this, both the threads can execute concurrently because the threads are using two different objects. A stack is executing, A stack will be using what? H1 object, B stack will be using H2 object. This will sleep, that will execute, that will sleep, this will execute. They will go on executing. From here, synchronization topic will start off. So that's the third example now. If you want write this example and then you can write the document for this example. See, this is the example now. Different objects. You know how do you make different objects referred? Means how do you make two threads work with different objects? How do you make? Simple. Directly create an object. I used to tell you now. Run method can create what? Objects of other class, call methods of other class. Yes. Now you are clearly seeing. Now this thread will have its own object. And A thread is having what? See here clearly, A thread implements runnable and it is working with H1 object. B thread is using implementing runnable and having H2 object. Now A is different, B is different. Now if you want the diagram for this, yes, see A stack. See, this is a thread stack. This is B thread. This is having its own run method. And in run method, what you have done? Hello, H1 is equal to new hello H1 dot M1. You are calling the method. Here also having run and you are writing hello H2 is equal to new hello H2 dot M1. So this is A thread. This is A thread, this is B thread. Now this will have its own hello object. This H1 is referring to this one. This one is referring to what? This one. Here you are having M1. It might be synchronized. Fine. But they are two threads are working on what? Two different objects. This is again synchronized void M1. Now they can run, no problem. You can put it to sleep. See, thread dot sleep. Here also thread dot sleep. Understood? So what will happen now? A thread starts off. It will sleep. That time what will happen? B thread will continue execution. This will continue. This is stopped. That will execute. That is stopped. This will execute. And almost all you will see the same output as the first one. What is that? 1, 1, 2, 2. That only you will be seeing. But two separate paths, but two different objects this time. So do not get confused with the first example and the third example you are seeing. Do not get confused with the first example and the third example. Reason is first example, two threads, same object, unsynchronized. First example is two threads, same object, unsynchronized. Third example is two threads, two objects, synchronized. So this is the program now. Output will be same as what? The first one what you saw. Almost all same. But the concept is totally different. Two threads are using two different objects. Clear this? Yes, if you are getting a good grip of synchronization now. Okay, let's continue and you'll get more clear ideas on synchronization now. So assume that there are two threads T1 and T2 where T1, now the explanation for the diagram now. Assume that there are two threads T1 and T2 where T1 is trying to invoke what? M1 with H1 object and T2 is trying to invoke M1 with H2 object. In this case, both the threads can execute concurrently because both the threads are using different objects. Different threads using same methods with different object. Clear this? Any questions? Fine. Okay. So some points we'll start seeing now. Shall I clear this diagram now? So in the case of method level synchronization, the object which you are using to invoke the synchronized method will be locked. You are saying the h dot m1. Which object you are using to call the method? That object will be locked. H dot m1 means hello object will be locked. See here, in method level synchronization what happens is, you are calling now h1 dot m1. Now hello object will be, h1 is an object of type what? Hello. Hello object will be locked. Understood? Whichever object you use for invoking the method, that object will be locked now. Fine. An object can have more than one synchronized method. Remember that. We will be seeing more examples for that now. Right now I am showing you only one synchronized method. So these are concepts now we have to see with what? More examples. An object can have more than one synchronized method, but there is only one lock for that object. That is very important for you to understand. That's why I am telling very clearly in the next point. The locks are not per method, They are per object. Okay, a class can have both synchronized and non-synchronized methods also. So a class can have many synchronized methods. A class can have synchronized and non-synchronized, whatever the combination. But finally for your object only one lock is there. Understood? Yeah. So are you clear with method level synchronization? It's a very simple topic. Any doubts with method level synchronization? We can do synchronization two ways. One is what? Method level. Second one is block level. So method level completed. Any questions? I told you we can implement synchronization two ways. Method level, block level. Method level is over now. Till here. Any questions? I'll move to block level. Block level is also very simple. Understood? So let's see the example for it first. Then you'll understand the document. See, open the fourth one now. 3 examples over now. So I'm going to what? Fourth one. To show block, I'm going to 4. Understood how to go now? 1, 2, 3, fourth example. So go to fourth example. Yeah. So now see, in hello, M1 is not synchronized. Same story. Hello has not been synchronized. Again we'll come back now. One object, 2 threads. Again we'll come back. One object, 2 threads. Pass the reference. You know how to do it. One object, 2 threads. How will you do it? Pass the reference, man. The same. Okay. So you are going to create the object of hello and pass the reference of hello to what? A thread also, B thread also. See here in main what you have done. Yes or no? Same thing. So 2 threads, same object. And only thing is now M1 is not synchronized. So how to put lock onto the object now? Understood? So I'll use block. See how I'll do? It's very simple, very very simple. In the run method, this is a block. You know if block, else block. Same way this is block. And don't get confused. This is not an argument. See, when you write if block also, how do you write? If some condition is right, you write no, if I is greater than 5. Yes or no? No, that is not an argument. Understood? Methods have argument. See, M1 in time means argument. Okay, this is a block. If is a block, but still you are giving some value. Or if you will sometimes tell, if boolean B, correct now? Boolean B is equal to true. How do you write? Boolean B is equal to true. Now if B means, is this argument? No. So that's why don't get confused. It looks like what? Method, you are sending an argument. No. This is a block. Now which object you want to lock? Hello object, no? Pass that now. We generally, even when you are reading books we tell, we'll pass that as a argument only. But it is not a method, it is a block. Understood? That's it. Now it is locked. When M1 is calling, no, before calling the method, what you do? Put a lock. Each object is synchronized now or locked. That's all. Understood? Now what is the difference between method level and block level? Can you tell now? What is the difference? Or when will you do it? See, earlier you know how you are doing synchronization. Nothing you are doing. See the second example I am opening. com.cluster.synchronize.method 2 synchronize. Earlier you are just calling M1. Notice here. So why? Because M1 was synchronized. M1 was here. M1 is synchronized now. When M1 is synchronized, what did you do in the run method? Just called run method. But now what did I do? Since M1 is not synchronized, doing this. But what is the difference? Or when is this advantageous? This approach, block approach. In sometimes there will be classes written by third party people. Somebody will write the class. And now I want to put a lock onto that object. I want to use their object now. And I want to put a lock onto somebody's object, third party object. Now I can't go and modify their code now. Can I go and write synchronized void M1 in their class? Now this is a class written by whom now? You. Can I, means you had your own idea of writing your method. And now suddenly I come and make that method as synchronized, doesn't look good. So we are not supposed to, oops, strictly tells what? Do not modify anybody's class. Okay, so I cannot modify somebody's class. But sometimes what happens? I'll be forced to put a lock onto somebody's object. But that is not the class written by me. So that is when you can take this approach. What will take? block level synchronization. So synchronized block helps you to lock what? Synchronized block helps you to lock. So don't be clear when I am pronouncing something here. Block and lock. Synchronized block helps to lock what? Helps to lock. Understand? Block, lock third party objects. Now why do you want to lock third party objects? Because that's a class not been written by you. If hello class was not written by me, how will I put a lock onto it? So this approach you can take. Very simple now. So the full object will be locked now. Which object? The H object. You are calling H.M1 now. That object will be locked now. See here. See, everything is same. You are passing the reference, everything you are doing same. Only what you are doing is putting a lock onto H object like this. This is a great advantage of block level synchronization. Clear this? Yeah, so we can lock third party objects. Output is same, there is no change. Even though now, see, even though now there is M1 is not synchronized. See, even though M1 is not synchronized, what will be the output? Same, because the object has been, when H1, when A thread is using that object, lock has been put. So till A completes execution, B cannot use that object. So B will be put into blocked state. From B, from new it will come to runnable. From runnable it will come to running. When will B thread come from runnable to running? When A thread goes to sleep. When A thread goes to sleep, B thread will come from running to runnable. B thread will come from runnable to running. But since it cannot get the lock onto the object, it moves into the blocked state. Understood? So one more is what you can do. Always you open this document and keep. It's very important. Which one? Life cycle diagram. When it moves from which state to which state. So when A thread, two threads will be, A thread and B thread will be in what? Runnable. So when A thread and B thread are in runnable state, one thread will come to running. It will be using what? Hello object. When it is using hello object, it will go to sleep. Now B thread will come. It will try to use the object. But since it cannot the hello object, what it will do? It will be moved into block state. B is in blocked. A is in what? Sleeping state. B is in block state. A is in sleeping state. A will come back to runnable and to running state. A will come back, but B is still waiting in the block state. So A will go on cycling, and then what will happen? B will, when the lock is released, when the lock is released, now B will come from block state to runnable state. Now it will go on executing, running state. It will go on executing. Again that thread also will go to what? Sleeping, runnable, running. Sleeping, runnable, running. So first A will complete this cycle and then B will complete this cycle. So diagram is mandatory for you. Clear this now? So again I am repeating last time. A thread, B thread both in new state. From new what will they come? Runnable. From runnable anybody can come to running. So when one thread is using, it might go to sleep for what? 500 milliseconds. Running state is free now. Now supposingly if A thread was running, okay, and it went to sleep, B thread will come to use that object. Which object? Hello. It will come. Okay, but the problem is lock has been put onto that object. So what will it do? Goes to blocked state. Goes to blocked. So that is when A thread which was sleeping will come back to runnable and then again to running. So A will complete execution like this. When A completes execution, now the lock will be released on hello object. Once the lock is released on the hello object, now B will come from block state to runnable state, and from runnable state it will come into running state. And when it is running again, what will happen? B thread also will go into what? Sleeping, runnable. We have put in a loop. So 5 times it will also loop like this. Are you clear with the flow? Clear? Fine. So keep the diagram always and then only you will understand all this. Fine. Yeah, okay. So now see, block level synchronization, yeah, we can do it in this way. One is this way you did. All you do is what? Synchronized. Which here also same thing is happening. See, the thing is, we are putting a lock onto the object. Do not think that you are putting a lock onto the method. Always we put a lock onto the object. Okay, so if you use synchronized keyword, like this also it will be locked. Okay, or if you use synchronized with method also it will be locked. So in Java, if you want a lock on the object, enable the lock by using synchronized keyword. By default they have disabled it, otherwise what will happen? When multiple threads are using one object, what will happen? Same thing will start happening now. By default the lock has been disabled. Why they have disabled the lock? Now see, you are thinking synchronization is good, but sometimes what happens? If you do too much of synchronization, what will happen? It will bring down the performance of application. Why it will bring down? Till one thread completes execution, another thread cannot complete, no. So it should be in a very good position to decide when to go for synchronization, when not to go for synchronization. Right now I am teaching you how to do synchronization. Next we will discuss advantages and disadvantages of synchronization. Okay, next we will decide advantages and disadvantages. First learn what is synchronization, what is the problem, how you get the solution. Then we will see what is the advantage, when to do it, and what is the disadvantage, when you should not do it. That we will see next. Clear with this now? So we will come back to that topic also. Anyway, this is done now. So I have completed the third example, and this is the explanation for what? Yeah, so we will come to that. This 1 second. Now block level, one more example I got. So after the third exam, which one? Fourth, and now I will move to which one? Fifth example, to show you again what? Block only. This is one more example for block level synchronization. See, block level synchronization also is done when sometimes you want to put only a few statements inside a, no, you don't want to lock the full method. I don't want to synchronize full M1 method. I want few statements inside M1 method to be synchronized. Only few. Not all, because one M1 method is having around thousands of lines. In thousands of lines I want what? Only some few lines to be synchronized. So that is when we don't make the whole method as synchronized. What we'll do now? We'll make only few statements synchronized. See now, among these many lines, how many lines are there in M1 method now? How many lines are there in M1 now? Begin of M1. That's one statement. Then I'm saying synchronized. But what is the syntax I'm using? Notice this. I'm putting the lock on the current object. Now whichever thread comes to execute this method, now that thread will put a lock onto hello object. But you should know the difference between synchronized of H and synchronized of this. So this, now see, this has been used in what? Hello class. Earlier synchronization how you are doing? In some other class, in A implements runnable, you are telling synchronized of H. Here I cannot say synchronized this. If I say synchronized this, what will happen? It will affect A. Understood? So fine. So what you do here? In synchronized of this, the syntax you understand now. So when one thread is entered, see here both the threads can come parallelly. But once one thread gets a lock onto this object now, the other thread has to wait. See the output now, you'll understand it very clearly. See, begin of M1 by A thread, fine, and it enters the synchronized, which one? It enters the synchronized block now. See the code. Begin of M1 by which one? A thread. It will print that. Begin of M1 by A thread. And then after printing, the A thread is trying to execute what now? There are two threads, A thread and B thread. Two threads are there. Okay, when A thread and B thread are trying to use the same object, now what is happening? Both are calling M1. So first A thread is decided to execute and it is printing this. And it will enter the synchronized which one? Block. This is synchronized block. Inside the method there is a block. Okay, so once it enters the block, fine, it will print this what? Inside for loop of M1 by A thread. See, it is executing this line also. Inside for loop of M1 by A thread. So you are seeing the output of what? A thread is entering M1 and at the same time it is beginning the loop also. Once it begins the loop, where it will go now? It will go to sleeping state. Now the other thread is there now. It can enter M1. M1 it can enter. And it will print what? Begin of M1 by, see here, begin of M1 by B thread. It's printing begin of M1 by B thread. Method it has entered. Both of them have entered the methods. But B thread cannot enter what? The synchronized block. Now you see, it has entered. but inside the loop only A is there. After end of means after the A thread completes execution, after A thread completes execution and releases the lock, now B thread will continue what? Begin of for loop by B thread, begin of for loop by that's one, inside for loop of B, inside for loop of B. Are you following now? So you are locking what? Few statements. So the advantage of synchronization block level is you can lock third party object, or sometimes you can lock few statements inside a method. So how do you should know the difference now? How do you lock third party object and how do you lock statements inside a method? If you want to lock third party object, synchronized of H, the variable name you'll pass. If you want to lock few statements, synchronized of this you'll say. That's all the differences. Are you clear this now? Any questions? See the output. Are you clear? See here. Clearly understand the flow. First you get a print of this now. See here. Understand the method, how it has been written. M1. Begin of M1. After begin of M1, synchronized of this. Now the block starts. Now the block is starting. And when the block starts off, what is there in the block? A second. So look at the M1 method carefully. When the block starts off, it is looping. It goes to sleep. And then what? End of M1. But till the see now one thread, when it is entered the synchronized block, both of them will come here. But when one thread enters the block, the other thread has to go. It will go into the block state. It will go into the block state. So first understand the code, then you'll understand this output now. See this, begin of M1 by B now. Fine, B thread has taken the lock. B thread has started to execute. B thread starts. It will enter which one? M1 method. B thread starts and it will enter M1. It goes into the for loop, but it is in which state? It is in which? It has entered the synchronized block. When it entered M1, it was not in synchronized block. Okay, when in M1 now it is there in for loop, synchronized block. So when it is there, now what happens? It is going to sleep. B thread goes to sleep. When B thread has gone to sleep, A thread is executed by A thread executes M1. A thread executes M1, but it cannot enter the block, synchronized block. It cannot enter. Notice it is locked. So the lock has been put onto which object? Hello object by B thread this time. Lock has been put onto hello object by B thread this time. Until and unless the method completes execution or the lock is released, A thread cannot execute. So this you have to understand, and this is a very important interview question now. There are two advantages with block level synchronization. We can lock only few required statements inside a method. That's one advantage. Yes, we can lock only few statements inside a method, and we can lock third party objects whose methods are not synchronized. Understood? And this is the syntax. What is the syntax for this one? Synchronized of some object. Any object you can pass. Clear? Fine. So now these are the two differences. Difference between method level synchronization and block level synchronization. What are the differences? With this, the object you are using to invoke the synchronize means with method level. Which object you are using? H.M1. That object will be locked. Okay, here the object which you are passing as a parameter to synchronized block will be locked. And now in that method level, in this all the statements in the method will be locked or synchronized. All the statements inside the method will be synchronized. Here we can lock, we can synchronize only some statements of the method. And this with that we can lock what? Only the objects of the class whose methods are synchronized. Here we can lock objects of third party class. Understood? Here it will be locked. We can lock only the objects of the class whose methods are synchronized. Only whose methods are synchronized, they will be locked. Okay. Whose methods are not synchronized, they will not be locked. But there you can lock what? Third party objects also. That is the difference. Clear this now? Fine. Now we'll start understanding actually why we do synchronization. Understood? Actually why we do understood what is synchronization. It's about locking an object so that only one thread can access the object. That's it. How do you do it? Either with method level or block level. Very simple story now. But why do you do it? let's see one example first, then I'll go on to explain you why we do synchronization. First see one example. See here, same story, there are 3 threads this time, A, B and what? C. Same story, A, B, C, only one extra I have added, A, B and C. And all the 3 threads will use which one? Hello object only. Okay, method is synchronized, leave it. Whether it is synchronized or not, that is secondary now. Okay, but method is there. Which method is there in this one now? Hello, M1 is there. Okay, if you want to keep it synchronized, if it is not synchronized, what will happen? All the threads can access it. If it is synchronized, only one thread will access it. Okay, fine. But see, notice, there is an instance variable here called as X, and there is an Y variable, which local variable called as Y. You know the difference between instance variable and local variable now? Yes or no? What is instance variable? Instance variables belong to class and local variables belong to method. You know this. Instance variables belong to object actually. Instance variables belong to object. Okay, and the local variables belong to methods. When you see in the definition, when you are in the source code, you will be seeing instance variable at the class level. But when the object is created, instance variables belong to the object. So you know this much. Fine. Now all the 3 threads are accessing M1 method. Same story. All the 3 threads, how they are accessing? Same you know, no? H.M1, H.M1, in all the threads you call it. When M1 is invoked, they are manipulating the variables. X is getting manipulated, Y is getting manipulated. Okay. But carefully understand, there is one object. Means there is one copy of X. If all the threads access the object, okay, and modify X, what happens? It will go on overwriting. Means, the point is, all threads use the same copy of instance variables, but they will have their own copy of local variables. I used to tell you, no? What I used to tell you? Local variables come to life when the method starts execution, and they are destroyed when the method completes execution. We have discussed the life cycle of the variables. Okay, local variables come to life when the method starts execution, and they are destroyed when the method completes execution. Now H.M1 is called by 3 objects, means 3 times M1 is invoked. So Y comes to life 3 times. Y comes to life 3 times. But X is only once now. X will come into life what? Only once. So when will X come to life? When the object of hello is created. When the object of hello is created, that time it will come to life. Okay. Now what is the life of instance variable? When the object is dereferenced or at that time destroyed. When the object is dereferenced and destroyed, then the instance variable will be destroyed. So I should know the life and life of both the variables, which are instance and local. So you know this many things now. Yes, good. See, hello H is equal to new hello. What happens now? Object is created, but X is coming to life now. X variable. So what is the default value of X now? 0. And now see, we are after that the same hello object has been given to what? The same hello object has been given to 3 threads. 3 threads A, B and C. You are giving to 3 runnable objects A, B and C. After that you are starting the 3 threads. Now all the 3 threads, what they are doing? Start means in the run method what they are doing? They are calling M1. Once they are calling M1, in all the places here, in B also you are calling M1 method, in A also you are calling M1, all the 3 threads are calling M1. So in all the threads go on to manipulate X and Y. See the output, you only. See, X by A thread is 1 first, and Y will be by A thread what? 1 only. Now X by C thread is what? 2. Order you forget. All the 3 threads are executing A, B, C. But C manipulates X to what? 2. And the value of Y in C is what? 1 only. And again in B is manipulating what? X to what? 3. And Y in B is also what? 1 only. Means all threads are having local copy of local variables. All threads have their own copy of local variables, but they are using the same copy of instance variables. That is very, very crucial here. Are you following now? See, just I am saying X plus plus, nothing I am doing. Nothing I am doing, and I am printing value of instance variable by thread dot current thread, like this I am printing. Nothing else I am doing. Clear? Value of local variable by so and so. Clear? Nothing else I am doing. Are you clear with this? Okay. You remove synchronized also, same effect. There is no change. All threads will run it, but effect is same. Okay. Only they will run parallelly. That's it. See, X by B. Okay. That's it. See here, B thread first executes, then A thread executes, then C thread executes. But all threads are using the same copy of instance variable. Are you clear at this point now? Yes. Now we'll understand why we do synchronization. Understood? Sometimes one method, no, it will be manipulating what? Instance variables. See, end of the day, we write logics in methods. We'll come back to the same old story of Java now. We write logics in methods. In methods, what you might do? You might manipulate the instance variable value. You might use the instance variable. Anything you can do. So methods are always going to do what? Act upon instance variables. Always all the methods will act upon instance variable. Sometimes the logic inside a method will be big. Okay, the logic inside a method will be big. So till one thread completes the execution, you do not want any other thread to enter the method. Why? Because by chance if one thread has entered a method and trying to manipulate a value, okay, in the end it will manipulate. At the end of the method, see here, one thread M1, one method is there M1, and you have got a variable here, instance variable, int x. Now x will be manipulated in the last by one thread. Last, say around after so many lines. But if both threads simultaneously enter it, what will happen? One thread has taken the value and processing it. Another thread has taken the same old value now. Another thread has taken what? The old value. That becomes what? Invalid value. And invalid value. Are you understanding what is invalid value? Or dirty read we say. Dirty read means it will be, see, x is supposedly 1 now. One thread enters. Now A thread will have the value of what? It will be using the value of what? X as 1. A thread will be reading the value of x as 1. Correct. It will go on. But by the time A thread completes execution, okay, it will become 2. So the next execution which starts off should read it as what? 2 actually. The next execution which starts off should read it as 2. But the problem is both threads have entered parallelly. Okay, both threads have entered parallelly, and that is why this thread will use 1, that thread also use 1. And finally what you will get? You will get inconsistent results. So generally we synchronize methods, generally, you will not synchronize all the methods. We just generally synchronize the methods which will be manipulating the instance variables. Okay, maximum means where you want to protect instance when you want to protect instance variables. Okay, so that is when you go on to synchronize the methods like this. So we'll see an example for that. So I'll go with the next example. Shall I clear this now? This example you understood now? Any doubts in this example? Any doubts in this example? No? Fine. No doubts? 3 threads having what? Their own copy of local but using the same copy of instance. Fine. So now the last example. Sorry, not last, one more is there, we'll see it. Okay. So synchronization is done to protect what? Data when multiple threads are trying to use the same data. Okay, now see this. Same story, nothing is there. A, B, there is one class called as hello. Only your hello is having what? One instance variable this time. Same story, there is no change. And what are we trying to do here? In M1, what are you trying to do? I'll write the logic and show you for this. Okay, but first understand the logic here. So when one thread enters, you have synchronized it. When one thread enters, okay, what will it do? The value of balance is given to what? A local variable x. So what is the value of x now? 0. Because value of balance is 0 first time. Value of balance will be 0 for the first time. Okay, and it will be given to x. Finally, what will happen? X plus 1. What is the new value of means x plus 1 is what? 1. So that value will be given to what? Balance. So what will be the value of balance now? 1. But before it gives the new value to balance, what will happen? It is putting the thread to sleep. That you understand. So when one thread is sleeping, another thread can come and read the value now. What will it read as? 1 only it will read. Because still the value of balance has not been updated. Yeah, it will read it as 0 itself. When one thread is in the, see one thread, see it has, X value has been modified, but still balance has not been updated. For A thread has entered, the value of balance is given to X and has gone to sleeping state. It has left the what? It has left the running state. After leaving the running state, it has gone to sleeping state. When it has gone to sleeping state, okay, another thread comes now. And it will also get the value of what? Balance and give it to X. What will be the value this time? 0 only. Actually, fact is, till this method completes execution, that should not have been allowed because this is dirty read now. Method only has not completed execution and you are allowing on one more thread now. Understood? So this is what will end up in inconsistent results, we say. Okay. So let's see the output. Again, I'll explain you very clearly with drawing and all that. I'll explain you. See, if you synchronize it, this will be the output. Means 5 times it will loop and it will go on incrementing balance 5 times and then it will print like this. But if you remove synchronization, both threads will enter now and start reading what? Dirty read, means invalid data, or this is also called as dirty read. See, now I remove synchronized and I'll explain this output now. B thread enters, it will take the value of balance as 0. It will work with 0 value. A thread also enters, it will work with the value of 0 only. Both will update. A thread will update it to 1. Again B thread also will update it to 1. Again they will enter. Now next time A thread will read it as 1. Again B thread will read it as 1. And they will process it. So this is how you end up in inconsistent results. But I show you very clearly with all these things with drawing. I'll write and show you this now. So this is why you do actually synchronization. Okay. So we'll see this. Okay, see, the first is an hello object which you create, and the same reference will be given to what? A thread also, B thread also. Same scenario, there is no change. Only now we are started working on what? Instance variable, that's it. Till now in our hello object, what was happening? Instance variable was not there, but now I added a instance variable. Both the threads will start now. Means both threads, when you create, they'll go into new state. From new state, where they'll go? Runnable state. Any thread can come into what? Running state. Assume that a thread comes into running state. A thread. So once a thread comes into running state, what happens? That object, it will call M1 and object is locked now. If I put synchronized. If I put synchronized, it is locked. If I put synchronized. So then what will happen? Till it completes all this execution. Okay. That means it will go to A thread is going to sleep. See, when A thread is executing, what is it doing? In running, it will come to this line. Okay, what will it do? It will take the value of balance to what? A thread. I am talking about the execution of A thread. It is synchronized. The value of balance is given to X. What is the value of X? 0 now. Why? Because value of balance was 0. Then it will go to sleep. So the A thread from running state, where did it go? Sleeping state. A thread went from running state to sleeping state. Fine. Now the B thread tries to call the method, but it cannot call. Why? Because the lock has been put onto the object. Now B thread goes into blocked state again. B thread again goes into the blocked state. So once B thread is in blocked state, now what happens? A thread from sleeping state, it will come back to runnable state, and again it will come to running, and now it will continue this execution. This was still pending then. Still balance was not updated because it went to sleep in this line. So now what will be the value of balance now? 0 plus 1, 1. Earlier balance was 0, it is 1 now. And it will print it. Whatever the values it will print. And then again it will only continue execution. Why? Because it has got the lock. Again what happens? A will start off execution. The value of balance is what this time? It was updated. Last time it was updated to 1. So this time it will be having 1 value. The value of 1 will be given to X. Again it goes to sleep. From running, again A thread went to sleeping state. Even if it goes to sleeping state, what happens? B thread cannot access, it's still in block state only. From sleeping state, again it will come back to what? Runnable. Which will come now? A thread. B thread is in block, forget it. A thread will come to, from sleeping to runnable. From runnable, it will come to running, and now this line will be executed. Now this line will be executed, and this time the value of X is 1, 1 plus 1 is 2, the value of balance will become 2 now. Okay, again it continues execution. Which one? A thread only. B is in block state. Continues. Now again, what is the value of balance now? This time 3. The value of instance variable is getting modified every time. So it will be 3 now. So the value of X is what? 3. Again it goes from running state to sleeping state. From sleeping state it will go. And once it is sleeping, what is happening now? After sleeping 500 seconds, again it will come back to runnable. So like this it goes on. Are you clear? And once the method completes execution, finally when all this is completed, what is the actual value of balance now? When by the time A completes execution, what is the value of balance? 5. Now what happens? B thread will come from block state to which one? Runnable state. Block to runnable. From runnable it will come into running. Now it will call. So this time the value of balance is given to X. B thread is taking now. But what is the actual value of X now? Balance. 5. Because by the time A thread completed, the value of balance was 5. Now B thread will take that value. So what is that value now? 5. 5 will be given to X. Now B thread goes into what? Sleeping state. When B thread goes into sleeping state, fine. There's no other thread. But if it was there also, this object could have not been accessed. Lock is there. So then from sleeping state, it will come back to what? Runnable. It continues. Now what is the value of balance? 6. It is updated. So B thread is modifying it to 6. Then 7. Then 8, 9, 10. This is the actual output if you do synchronization. And this is what you should do. Means when a method is working on an instance variable, okay, you should always see to that. When method is using instance variable, till that method completes the modification of instance variable, do not allow any other thread to use the value of the instance variable. Understood? Till the method completes execution, okay, it might be manipulating the value of instance variable. It might be manipulating. So till it completes and till it completes the usage of the instance variable, do not try to use any other thread to use the old value because it will become invalid value. Okay, and should I have to explain you with the diagram now? Are you clear? A thread aspect runnable. See, both thread will be in runnable. Runnable to what? A thread is coming to running. From running, where it will go now? It will execute and go to sleeping. Now B thread from runnable, it will come to sleeping. Sorry, B thread from, I'll repeat it. Two threads in runnable, which are A and B. A and B are in runnable. They come here. A thread is picked, coming to running. When it is executing that method, A thread goes into what? Sleeping. Now this state is free. Scheduler will pick what? B thread, sends it here. But it cannot access that object. So it will go to block state. B has been put there. A comes from what? Sleeping state to runnable state. It will execute. It goes on sleeping. All that it will do. 5 times it will do. Loop I put. So by the time it completes the loop, balance has been modified to 5. And once the method completes execution, no lock is released. Once the lock is released, now the B thread from block state comes back to runnable state. It will continue its cycle now because 5 times sleep, it will go on. 6, 7, 8, 9, 10 it will print. Are you clear with the output? So first see with synchronized. Without synchronized, we'll see next. Same thing what I explained you now. Yeah? When A thread is using it, B thread cannot do anything with that. Yeah? Fine. If I remove synchronized, now you should be able to explain now what will happen. Very simple. See, B thread is picked first time. B thread is picked first time and it will take the value of 1. B thread has picked the value of balance. What is it? 0. B thread will take 0 value and it is given it to X. B thread will go to sleep. Now A thread will come. A thread also will do what? Take the same value. What it is? 0 it will take. And it will give it to what? X. Now both thread, okay, it will give it to X. Thread dot sleep. Both thread will go to what? Sorry. One second. So first B thread came. Okay. B thread took the value of balance as 0 and gave it to X. Once it is given to X, what happens? It goes to sleep. Which one is going to sleep now? B thread. Once B thread goes to sleep, what happens? A thread will come now. A thread also will take the value of balance as what? 0 and give it to X. Both of them have read it as 0 only. Again I made a mistake, one second. Okay, one second. Yeah, correct. Both of them okay, I have taken the value. Now both from sleeping state will come to what? When it is not synchronized. Why I am getting confused is I put synchronized there. If you remove synchronized, you have to talk. So now both threads will go to sleeping state. Okay. But when sleeping state, what happens? They come back to runnable. One thread will come now. Which one? A or B? We don't know. Here which has come? B. B has come. So that will take the, means it will do this pending work. What is the pending work? X plus 1. 0 plus 1. It will give it to balance and it will print. What it is printing? 1. A also will start off. But it had the previous value now. It had already taken what? Previous value of 0. From there it will continue. Again the instance variable is overwritten. But one value is only overwritten with what? 1. Same old 1 value is overwritten with new 1 value. Understood? So here also 2 times overwriting is happening. Then again what will happen? B will start, okay, B will complete execution. Now again, when one more thread A will pick up now. It will come now. What? It will be taking the value, it will be reading the value as what? 1. Then again the value of balance is given to X. Now A thread might go to sleep, but it has taken the value as what? 1. It will go to sleep now. Now because it's sleeping, what happens? B thread will come now. Once B thread comes, it will also take the value as what? 1. Now it will also go to sleep. Now both the threads will come now. Okay, now A will update it as what? 1 plus 1, 2. Now B might come. It has got the previous value, 1 plus 1. Again 2 only is overwritten. Old A thread 2 value is overwritten with B thread 2 value. So like this it goes on executing. Understood? This is the concept. Okay, so means see, synchronization is a very big subject. But literally we are trying to understand why synchronization is done. But in Java it is so simple. All you have to do is what? Just put on keyword synchronized over. Imagine what happens. Only one thread can use that object. Unbelievable it is. Okay, this concept is so tough to do it in what? Other languages. When one thread is using one method now, you cannot to not allow another thread to use the same method. It becomes very, very difficult. But in Java it is so simple. So are you clear with this now? Why you can see 2 times 1, 1, 2, 2? Because 1 is only overwritten twice. From A thread also, B thread also. Again from B, 2 is overwritten from B and A. Like that it goes on. Clear this now? Any questions? Any questions? Fine. Now, see this much if you understand about synchronization, fine. Okay, but some more points I'll give you, which you'll understand slowly now or sometime later. But this document what I prepared for you, it will be definitely helpful for you even if you have 4 years of experience. In 4 years of experience, people will definitely refer to this document. So that intensely I have covered. Some more things, documents are there. Slowly you'll understand. It's not that immediately you'll understand. Okay, as we go on coding in the further stages, you'll understand. But timing, the concept is clear now. Why you do synchronization? What is synchronization? Locking an object. Why do you lock it? When you want to protect the instance variable value, that time you will do synchronization. So all that. See some key points now about what? Every thread in Java will have its own copy of what? Local variables, but will use the same copy of instance variables when multiple threads are using one object. Is this point clear to you? Fine. The next point. Only methods or blocks can be synchronized, not variables or classes. Means don't use synchronized int I. Don't say synchronized class A. You should know where to use the synchronized keyword. Understood the meaning of this one? What? Don't try to do this, sir. Where? Just now I showed you, no? Yeah. Okay, now see this. Synchronized. This is error. You can't use synchronized keyword with what? Variables. You cannot use it with what? Class. These are all error. You can use it only with a method or a block. Understood? So you should know where to use it. To put a lock, what you do? You can use it, if you want to put a lock, you use it in a block or use it for a method. Fine. This is done. Next. An object can have more than one synchronized method, but there is only one lock. Understood? If one thread, I will be giving you scenarios and you will understand this. If one thread has entered a synchronized method on an object, then no other thread can enter any other method on the same object. Means if there are 2 methods M1 and M2, till now we have seen only one. Okay, but which one? Only M1. But supposedly there are 2 methods M1 and M2. And if A thread calls M1 method on hello object, B thread cannot call what? M2 also. And I'll give you example for this tomorrow. We'll be seeing this. Okay, but the point you understand, an object can have more than one synchronized method, but there is only one lock. If one thread has entered a synchronized method on an object, then no other thread can enter any other synchronized method on the same object. Fine. Next, if a thread has invoked a synchronized method on an object and has a lock, it has invoked a method on an object and then has a lock, the same thread can invoke another synchronized method, but the same thread can call another synchronized method on the same object because it is this thread which is having the lock on that object. Another thread cannot call another synchronized method, but the same thread can call another synchronized method on the same object. Yeah, we'll be seeing examples. Now, if a class has both synchronized and non-synchronized methods, multiple threads can access the non-synchronized methods concurrently. Understood? This point's bit confusing, but with more experience you'll understand. Understood? I've given you scenarios, you'll understand. If a class has both synchronized and non-synchronized methods, what? Multiple thread can access non-synchronized methods concurrently. I'll show you the examples. Tomorrow I'll be giving you examples for all this. Clear this? But get the point today. Now, static methods also can be synchronized. Yes. So you can synchronize instance methods also, as well as you can synchronize static methods also. Now see this. What is the syntax? Same. How do you do? If your method is static, static synchronized void M1. That's it. Static methods also can be synchronized. Now see, instance methods are synchronized to protect what? Instance variables, and static methods are used to protect what? Static variables. And there is no need to protect what? Local variables. This is where the whole subject stands now. Okay, static methods are used to, you do synchronization for static methods to protect static variables. You do synchronization for instance methods to protect instance variables. There is no need to protect what? Local variables, because all threads will have their own copy of local variables. Fine. Now see, the next important point now. Are you clear with this thing now? This clear? You understood why you synchronize static methods and instance methods? Till now I give you an example for what? Instance methods. Okay, fine. Now see, this is one more very crucial point. Okay. For every Java class loaded, the JVM implicitly creates a default object of type java.lang.class now. I've kept on telling you. Whenever a new class is loaded into the JVM, what happens? An object of type class is created. Yes or no? Same topic. For every Java class loaded, the JVM implicitly creates an object of type java.lang.class. This object also will have a lock. Which object? The class object. The class object also will have a lock. If you have a static synchronized method in a class, when the static method is invoked on the class, the lock will be applied on what? The object of java.lang.class. Understood? It will be applied on java.lang.class. Because see, supposingly there is a static method in hello class. Static method called as, see, this is your, this is it. Now how will I call it? Hello.m1. Fact is, there is no object of hello getting created now. Where is the object of hello? I am not creating the object of hello this time, because it's a static method. How am I invoking it? With the class name. So I'll invoke it with the class name, hello.m1. So what happens now? Class is loaded. But when the class is loaded, what happens? An object of class is created. Lock is put onto that object. Which one? Java.lang.class. Understood? Because there is no object of which one? Hello. There is no object of hello still. But object of class has been created, and lock will be put onto class object. That more information I'll give you next. Clear? Fine. Now see one more point, very interesting. If you have a hello class and if you have created two objects of hello class, understood? If you have a hello class and you have created two objects of hello class, now actually there will be how many objects? 3 objects. Why? 2 of type hello and 1 of type java.lang.class. Yes or no? Now fine, because class is loaded. When the class is loaded, class object got created first, and then 2 hello object got created. You understand now how 3 objects are getting created? When the hello class is loaded with the new keyword, hello h is equal to new hello class is loaded. Immediately what happens? An object of class will be created. And after that what happens? These 2 objects are created. Which one? Hello objects. So that's what. If you have a class hello and if you have created 2 objects of hello class, now there will be totally 3 objects which will be created. 2 of type hello and 1 of type java.lang.class. If a static method on a class hello is synchronized, and if a thread invokes it, the lock will be applied on what? Class object, not hello object. The lock will be applied on class object but not hello object. Understood now? So these points, you keep it in mind. Slowly you'll understand all that. Okay, next. See, these are your interview questions. These are your definite interview questions. Scenario 1. Okay, if I declare M1 as synchronized, what will happen? Tell what will happen. Read, you only read. You'll understand. The object which you are using to invoke the M1 method is locked. That's all now. If M1 method is synchronized, what will happen? When you are invoking it, that object will be locked. Next. Now see, inside a method fun, where? Fun method. In which class? Test. Class test is there, fun method is there. I have written one synchronized block and passing hello object as parameter to synchronized block. What will happen now? The hello object which you are passing to the synchronized block as parameter will be locked. Yes or no? I am using block level, but this time I did not lock what? Current object. I am locking which object? See, if I use this, current object will be locked. But if I use hello object will be. So you can pass any object to the block. Current object also you can lock, third party object also you can lock. Are you clear with this? So what is the answer? The hello object which you are passing to the synchronized block as parameter will be locked. Fun is not locked. Hello is locked. Understood? Fine? Understood. Understand the lock is put onto which object first. Fine. Yeah. See, I have, one second, let me show it fully to you. See, these are your definite interview questions. Read it properly. I have a class hello with two synchronized methods now. Which one? M1 and M2. And one object called hello is created for what? Hello class. One object is created. Two threads are there. Okay, see. I have a class hello with two synchronized methods first. Here only you can see, man. M1 and M2 are two methods. And only one object called as H. But there are two. Same scenario, but what? Two synchronized methods now. Two threads, single object. Two synchronized methods. What will happen? See this. And what is the question? Let's complete. Now two threads T1 and T2 are trying to use M1 and M2 respectively. Means T1 is trying to call M1. T2 is trying to call M2. Thread 1 is trying to call separate execution now. But the thing is T1 is calling M1, T2 is calling M2. Same object. No difference. Same scenario. In this scenario, only one thread can access object H, because see, when T1 holds the lock on H and is calling M1, then T2 is unable to access object H. Why? Because it is locked. After T1 completes execution of the method, the lock is released on the H object. Now T2 will hold the lock on H object and invokes what? M2 method. Now it will invoke. So these are your questions which you are having in mind. I am just clarifying. These are interview questions. Come your questions right now. Understood? You are having some doubts. I am clarifying all your doubts now. Clear? Next scenario now. I have a class hello with two methods, M1 and M2, where M1 is synchronized and M2 is non-synchronized. M2 is not synchronized now. Only one object. Same story. Only one object called as what? H. There are two threads again. T1 and T2 trying to access what? M1 and M2 respectively. With the same object, what will happen? Concurrently T1 can access what? M1 and T2 can access M2 on the same object. This time concurrently they can access. Because T1 is working on object and for T2 no lock is there. For M2 there is no lock. We tell for M2 there is no lock, but actually I am telling you very clearly, object is on what? Lock. But if you are calling non-synchronized method, for that time that object will not be having any lock. It will allow you freely. So this is what you have to understand. So lock will be only for when you are calling a method. Which one? See, get this point. A class hello with two methods M1 and M2. One is synchronized, one is not synchronized, but still there is only one object for this. One lock. One lock for this object. One lock for this object, and that lock will be enabled when one thread is using this object. When thread is using this object, it is enabled. But at the same time, even though it is enabled, T2 can call what? Non-synchronized method. M2, it can call it. So that's the answer. Concurrently, T1 can access M1 and M2. T1 can access M1 and T2 can access M2 on the same object H. Yeah, you can access concurrently. You'll be seeing with examples. That's why just understand all the scenarios. Now I have a class hello with method M1 which is synchronized and static. What will happen when I call the method M1 with class name? Just now I had explained to you. In this case, the default object of java.lang.class will be locked. That will be locked. Now, if I have a class hello with two static methods, filter that now. If I have class hello with two static methods which are synchronized, what will happen when one thread T1 is calling M1 with class name and another thread T2 is calling M2 with class name? What will happen? Same object is there, you cannot call. When T1 is accessing M1, the default object of java.lang.class will be locked. Then T2 is unable to access M2 with the same default object, because the default object is already locked by T1. Same. Now, some more questions. These are all your interview questions, man. More than that, nothing can come in what? Synchronization. If you read this much, you can clear your interview on synchronization. Okay, next. When should you do synchronization? Yes, it is done to protect what? Data when two or more threads are concurrently accessing method that is making manipulation on the data. When is the lock on the object released? It is released when the method completes execution. What is the race condition? Some interview questions. It is a condition where multiple threads are racing against each other on the same resource to complete execution in a method. Okay. Synchronization is done for avoiding race conditions. That's one more way how you put it. Okay. So what are the drawbacks of synchronization now? Finally, drawbacks. It restricts concurrency. Yes or no? That's one problem. It restricts concurrency because multiple threads cannot execute the same method at the same time. And because of that, it brings down performance of an application because all threads who want to access the object have to wait to get the lock and then continue execution. It can also cause deadlocks. So this is where the deadlock concept will come. There's an example I'll show you. Understood? So synchronization, if you don't do it properly, it can lead to deadlock. Hold on to that. I'll give an example for that. See, what is deadlock? Deadlock can occur in a situation where when a thread is waiting for an object lock that is acquired by another thread, and the second thread is waiting for an object lock that is acquired by the first thread. Since both threads are waiting for each other to release the lock, the condition is called deadlock. So X thread is using A object, and A object might call means again X thread might need what? B object. Y thread is using B object, and again it might need A object, and sort of lock will be applied. I'll show you that. Okay, but before I show you that example, two small questions will complete, and then I show you that example. See, what is starvation? It is a condition when one thread is waiting for other thread to complete execution for a long time. For a long time. These are some terminologies, man. What is starvation and all that. Now, what is the difference between starvation and deadlock? Starvation means long time waiting. Deadlock means forever waiting. If starvation is serious, it is converted to deadlock. Some interview points, that's it. Are you clear? Now we'll see the example in deadlock and complete the class. That's it. The 8th example. Yes, two threads, two objects you need now. Yes or no? You need two threads and two objects. Okay. So this is one class A. What is class A having? It is having two synchronized methods. Yes or no? What are the two synchronized methods? Foo is one method. M1 is one method. Always do not forget, get into first what? Members of the class. Do not get into the code. First see what? Members. What is there in the method we'll see later. First always understand members of the class. There are two methods now called as foo and M1. Both are synchronized. Now what is foo trying to do is, it's trying to call M2 method of B. That's it. Understood? And likewise A will try to call what? M1 method of class A. Understood? So see, B will try to call M1 method of class A. Both are synchronized. So let's see what happens. But anyway, these are the two classes A and B. I'll not write any diagram. You have to do all this now, homework. Actually this is your homework. Okay, and do not come to me for doubts on this now. You have to put diagrams, understand all that and do it. Now see, what am I doing? If two threads want to use the same object, what should I do? Pass the reference of both the objects to both the threads now. If two threads want, till now I was passing what? Single object to both the threads. Now what will I do? I'll pass both the objects to both the threads. Very simple. Coding wise you should know now. See, this is the constructor of X. I am passing what? A also, B also. Similarly in Y, I am passing A also, B also. Fine. So now what is X doing? It is calling which method? Foo method. What is Y thread doing? Calling bar method. But again you know, foo is calling what? M2 of B. And bar is calling what? M1 of A. Understood? So draw and you'll understand all things. Now I'll create, see, first I'll create two objects. Which one? The two objects on which you want a lock. So A and are the two objects which will be used by two different threads now. Those two things I'll pass it to what? Runnable. So X and A and B is given to X thread also, A and B is given to Y thread also. Understood? But X will call one method, Y will call another method. Understood? So like that. And you'll start off. That's it. So go through, you'll only understand. This is deadlock. Finally you'll say, See, this method will not execute. Which one? You are calling here now a.m1. It will not execute. See this output. Deadlock will happen. Entered. Forget the main thread, you forget. Entered a.foo, entered b.bar. Trying to call m2, trying to call m1. But neither m2 is getting executed nor m1 is getting executed. Understood? So that you put diagrams and you will understand what is deadlock now. Are you clear now? So I give you an example for all the states now. Only what is pending here? Waiting state. Okay, we'll be seeing it in the next session. So but see, remember, this is your assignment, what I have told you about deadlock. Okay, go through this. Okay, so if you have any other questions, you can ask. This completes the synchronization on multi-threading and synchronization. Synchronization and multi-threading otherwise. Definitely, if this document is so highly valid that you can clear even 3+ years of experience or 4+ years of experience. That to that level, I prepared all the examples and document for. Yeah, highly valid. Provided you'll understand, you go through the examples, work. Understood? Any other questions you're having? Ask. Clear? Clear now? Okay, that's it.